Sorry about that. I had a family member knocking at the door. Here I have the final equation. Since the largest exponent, or not exponent, but right here, this 4, since that's even, it means it will point in the same direction. And by same direction, that means this. Just like that. A function that doesn't point in the same direction will end up with one end going down and the one end going up like that. With it being the same direction, this final thing goes up like that. So since it's even, it means it kind of mirrors it. Not really mirrors it, but it means it points in the same direction is the best way to say it. And then to find out if it rises to the right or to rises, we look at the first exponent, or the leading coefficient. And since the leading coefficient is technically a 1, because remember, nothing there is a 1 unless it specifically states a 0. Nothing there, we assume it's a 1. So 1 is a positive number. It's not below 0, so it wouldn't be a negative number. It's a positive number. We can assume that this function rises to the right, hence like this. Okay, and now on to B, x-intercept. Here we'll do what we've already learned before, and we'll put 0 in for y. So we have 0 equals x minus 2, x plus 4 squared, and x minus 1. So right in here, we'll do x minus 2 equals 0, x plus 4 squared equals 0, and x minus 1 equals 0. These are to find all the x-intercepts. So x minus 2 plus 2 on each side, x equals 2. X plus 4 squared, well first let's get rid of the square, so we square root both sides. Square root of 0 is 0, square root of x plus 4 squared is going to be x plus 4. So we have x plus 4 equals 0, minus 4 on each sides, x equals 0. X plus 1, or x minus 1, we plus 1 on each sides, x equals 1. So these are all the x-intercepts for this parabola. When we go on to C, now this is asking if it bounces, where the x-intercepts bounce and where they cross. So an easy way to say this is the square root. If it's an odd square, it crosses. If it's an even, it bounces. Well, since x minus 4 was an even square root up here, that would be a bounce. Meaning that if this is the x-intercept, parabola, it comes up and it touches and it goes off. It just bounces right off of the x-intercepts. So since x equals 2 and x equals 1, since those have odd squares, which is still an odd number, that means both of those actually cross it. So in reality, the whole parabola looks like this. Come up. So remember, it's even and they point in the same direction. So it's even, it rises to the right, points in the same direction, bounces at x equals 4. The y-intercepts right here, bounce at x equals 4, negative 4. And then x equals 1 is right here, and x equals 2. So these are the x-intercepts right here. 3 of them. Alright. On to D. Let's try to find the y-intercept. We do the same thing that we learned before. We put 0 in for x. So then we get x equals negative 2, positive 4 squared, and 0 minus 1. So we just, 0 minus negative 2 is negative 2. 4 squared is going to be 16. We do that down here, and then 0 minus negative 1, 1. So down here we have negative 2 times 16 times the negative 1. 2 times 16 is 30. It's negative 32. Negative 32 times a negative 1. Right here, a positive 32. And that right there is our y-intercept. So right here is y of 32. And this is 1, x1, and x2, and x negative 4. So this is exactly what a parabola looks like. Obviously, this is not to proportion at all, but that is what it looks like. And then finally, we want to find the turning points. Well, it's not even the turning points, it's the number of turning points. So, n minus 1 is the max number of turning points, and n is the largest degree. So I got 4, because up here, remember, 4 is the largest degree, x to the 4th power. So 4 minus 1, there are 3 turning points. 1, 2, and a 3. On to the final problem now. The final problem, we got f of x equals to x minus 1 divided by x squared minus 4. So, to find the domain, we want to get the denominator equal to 0. So, we're going to take x squared minus 4 and we're going to make that equal to 0. So, we'll minus 4 on this side, so x squared equals 4. Now we want to get rid of this square. So, I'll put that over it, and then the square root of 4 is actually 2, because 2 times 2 is 4. So we get x equals 2. Actually, I stand corrected. Since we take it off of the x, we have to get plus or minus 4, square root of 4. Then we get x equals plus or minus 2. So 2, negative 2. Excuse me, meaning that the parabola, it goes infinitely, the domain goes infinitely negative, goes to negative 2, and from negative 2 it goes to positive 2, and then from positive 2 it goes infinitely positive. The y-intercept, as we stated before, do 0 for x, so y equals 0 minus 1. Y equals 0 squared minus 4. Well, 0 squared is still 0, 0 minus 1, so then we just get negative 1 over negative 4. So, negative 1 over negative 4, well, negative divided by negative is a positive, so we just get a positive 1 over 4. 1 over 4 is the y-intercept. X-intercept, 0 in for y, so x minus 1 over x squared minus 4. So, let's get the numerator. X minus 1 equals 0. Take that negative 1. 1 on this side, 1 on this side. X equals 1. That will be the x-intercept. The vertical asymptotes, we want to take the x plus or minus 2 and bring it down, and x equals 2 and x equals negative 2. These are what it cannot be, and this is the vertical asymptotes. This is where if the equation looks like this, it's really hard to draw. Okay, ignore. It's really hard to draw looking at my camera, but if the equation looks like this, the vertical asymptotes is going to be this center line right here. And keep in mind that this does not have to be the y-axis. The y-axis can be right here. So the vertical asymptote is going to be this part of the equation meets in line with this part of the parabola. Lower horizontal asymptotes, I take the denominator and the numerator. So the denominator is x squared, and then the numerator is 3x. The, what do you call it? The square of x squared is larger than the square of just 3x. So the denominator is bigger than numerator, y equals 0. So the vertical asymptote is at -2. So if this is 0, this is -2. The y is 0, so that means it's along the x axis. So this 0 is our y-axis. This 0 right here is our x-axis. The horizontal asymptote is right here along the x-axis, and the vertical asymptote is actually -2, or 2 points over from the y-axis in the negative direction. So we got the two parabolas right here again, one right there, one right there, and they meet along these lines. Alright, that is the end of this video assignment. Thank you.